You too could buy your very own straight out of Benson shirt for $10. They're down in the bookkeeper. They are made by your very own tech algebra class of 2015 here at Benson High School. So, also, if just to point out that you could be in that class coming up with the designs and printing them on shirts next year if you choose to be. Okay. What's that stuff? Is that your stuff?
I believe this is mine, this is yours.
Can I have that? First off, we, as a reminder, are going to have a guest speaker tomorrow. And we talked yesterday about the expectation.
Is the guest speaker going to just be the entire day? Just be here the entire day?
Yes, she will be here the entire day, and she'll be having your attention the entire day. There will be the entire class period. Yeah, there's going to be some different stuff. Raul's doing a really good job of showing you exactly what not to do tomorrow. It will be unacceptable. Here's what's going to happen tomorrow if Raul does that. I'm going to go over, I'm going to tap on Raul and say, hey, scoot. And you're going to go down and sit in Mr. McMahon's office. Okay? We've warned you, right? Not even warned you. Like, I shouldn't even have to threaten you. Right? It should be common courtesy to pay attention to someone who's talking to you. Okay? So just asking, again, that you guys are respectful, polite, upstanding young individuals that you are. Okay, same thing, right? I have a meeting after school today. Guess what? I don't want to go. Too bad for me. I have to go anyway. Okay? And guess what I don't get to do? If I go to a meeting and I go in and I just go, ugh. Now I'm paying attention, my head's just, if my eyes aren't closed, I'm just thinking, right? I'm going to lose my job. They could literally just fire me because I don't have appropriate workplace conduct. Okay? Luis also doing a fine example of exactly what you won't be doing tomorrow. Yeah, you want to be sassy about it? Math. Are you doing anything right now? No. Should you be listening to me? Yes. Yeah. Let's try. Okay, just as a reminder, we talked about it. You're sitting up. You're making eye contact. Right? The whole time, not just once. So like Mitchell, you're probably going to want to move your chair for tomorrow. Because if you're sitting right there, you're going to be awkwardly going like this the whole class, you know. Okay? Yeah, maybe a smile, that's nice. I don't even care if you're sarcastic. I'll take it. It makes me feel so good when you guys are sitting up looking. I'm like, yeah, they're paying it. What's happening? But Zanaya's like, I got to finish my homework. So, I don't know. Yeah, winking. It's good, it's good. Okay. Anyway, that's enough about that. We already talked about it yesterday. Also, there was something else. Oh, well. I'll remember what. It'll come back to me, I'll tell you. Here you go, warm up. How about 1 through 6, please?
No, it's just
you?
one day.
Yeah, go back down. You're not marked late, you're going back down.
Do you not believe it?
Okay, first one, let's just do this. If you didn't do it, the first one, then you know what, you're behind and you deserve to be called out. That's kind of how I feel at this point. I say that kind of lovingly, but also kind of like if you didn't do the first one, like I don't know what to tell you.
Dun, dun, dun.
Is that you, Badger? I think it is.
Oh, that is good.
Badger's gonna tell us the first thing he did.
Just the first step.
Sure.
I did a squared plus b squared equals c squared. I just wrote that down.
Okay, second step.
I squared 4.
So you wrote, did you write it maybe? Did you write 4 squared?
Yeah.
Plus?
Oh yeah, 4 squared plus 7 squared equals x squared. Because it's just x.
You guys want it to be x or c? C. Yeah, I knew it. I just knew it. We can't go writing different numbers in there. Whoa. If you wrote x because you wanted to be savvy about it, that's cool too. If you wrote x, you probably don't care if I write c. But if you wrote c, you're like, don't write x. Okay. And then, of course, what do we do?
After you figure that out, you define the square root of.
Wait. Figured it. Square them. Zanai's going to help you explain. 16 plus 49 equals c squared. And then I add them and I get 55. And Badger, how do I do that? What?
You figure out the square root.
Yeah, opposite of squaring is square rooting. Square root, square root. The square root of 65 is approximately 8.06 inches. Notice I wrote approximately. Notice. I was like, hey, that's approximate. That's not an exact answer. More to come. Okay, cool. We okay with that one? Now, here's what some of you guys did. Some of you are like, yeah, I am so kicking butt at this Pythagorean theorem. Boom, shakalaka. I know how to do this. Yeah, good. Okay? No, if you wrote 11 squared plus 13 squared, don't start patting yourself on the back because you messed up. Okay? C squared, C of the Pythagorean theorem fame. C is always what? C is what? Hypotenuse. We know hypotenuse is always the longest side is always opposite the 90-degree angle. C has to be the hypotenuse. This is math voodoo. Okay? I would have to write this as, maybe you want to call this a squared. You want to call that a? Okay. A squared plus 11 squared is equal to 13 squared. Okay. C must be the hypotenuse. If you fell for the trap, right, you're wrong. So, say something. Go on squaring things. A squared plus 121 equals 169. Then now we're talking a little bit about solving. We haven't quite talked about it formally here. Solving, process of undoing, process of opposites. How do I undo plus 121? Chris from the back. Subtract 121 just like that. I'm done? Yeah, from both sides, always and forever. You've been solving for eons at this point, right? You guys have done that a bunch. 120, those guys cancel out. I'm left with a squared is equal to 48. No, is that right? Don't say negative. 48. If you got negative, something real bad happened. And then, of course, just like before, to undo a square root, these guys cancel each other out. It's all about canceling things out, balancing it out. And so then I get the square root of 48 is approximately 6 what? 19?
92.
Is he right?
Yeah.
So is that as much notation as you need?
Sure. That'll work. Okay. Oh yeah, homework. I would like to tell you that I have a plan in the works about a competition between you guys in third period.
Ooh.
And I'm also going to tell you before I get the plan, I'm ironing out some details, but you guys are currently getting your butts kicked. Okay? Just so you know. In how many of you did your homework.
Oh.
There are about, it's going to be some sort of, class party, I think. Something. I'm ironing it out. It's me just milling it about. Okay? It'll be a fresh start once I announce the competition. Otherwise, you guys will lose. Okay. We're not even gonna. What I would like you to do right now is please take 6 minutes to discuss 1, 2, 3, 4, 5, and 6 thoroughly, completely with your group.
Okay.
On your test, you got a score for G3, a score for G8, and a score for G1. Those were not set in order. Okay? If you did not pass, passing is 2 or better. If you did not pass any of the three, technically you're not currently passing the class. Okay? Now there's still loads of room for improvement. And in fact, overall, most of you guys really improved. I went back and changed a lot of quizzes. You know, you should double check, because if you, let's say on G8, a lot of you guys did really well on G8 and you get a 4 on it. Then your grade on G8 is now an A. Okay? You might want to check when you go into Synergy that I changed it right. Because you probably are more invested in looking at your one grade than I am, or you should be. Yeah?
What if you got a higher score on one of these things on a previous test and you didn't pass this test?
Yeah. So some of you guys are going to be in this boat where you got like, I don't know, hypothetically, quiz, maybe you did like this. I don't know. Okay. I do not go back and change those to ones. I don't go change them to ones. And this is where Synergy, you kind of are taking a gamble. Okay. Technically, would you be passing? No. Should you retake that? Yeah. Synergy might still give you a C or a B, just because it would say here, I don't know, I would say this is about a 2. Okay, you clearly know something, I don't know what happened to you. And oftentimes, maybe, there's reasons, right? There's sometimes you get it wrong because there's one little piece that you are confused on. Sometimes you get it wrong because you have absolutely no idea what's happening. This person is not someone who has no idea what's happening. Okay, so there's that to be said. There's also to be said is that you guys are going to take more G8 quizzes. We're going to keep going with that thing. There's going to be more quizzes. There's going to be more quizzes. In fact, you know what? G8 is going to show up again on your Unit 2 test. Just to tell you. Okay? Yes, Tommy? Yeah, great question. So, still, that being said, some of you guys don't want to sit with an F in the class. Okay? Here's what's going to happen. If you have a 1 on any of the sections, you're going to retake either just that section. And if you have said, well, poopy, I got a 1 on all the sections. Okay? Then, right, we work on it section by section. Now, that being said, we'll continue to call, whatever. If you got a 1 on all the sections and guess what, you haven't ever come and talked to me about it, like, I'm not really surprised. And, I don't, you could still turn that around, though. If you didn't pass something, you need to come in and this is the time of, now it's clearly time for some one-on-one work, okay? So yeah, you have to come in before school, and you have to come in to meet with me, and we have to talk one-on-one and figure out why you're getting them wrong. Is it because there's a small mistake? Is it because you have no clue? And I'll give you some practice problems depending on what it is, right? It's basically like tutor time. You have to come in and get tutored by me. Okay? And then at that point, when I feel like if it's one morning, if it's a few mornings that you need, when you're good, I'll say, okay, great, let's set up an appointment for you to come in and retake your test. And you'll say, okay, Miss Stolte, I want to come into tutorial next week. I'll be like, great idea. We'll set up a time. You'll come in, you'll retake it, all will be well. I won't let you retake a test unless I think you're ready. I think you're ready if you have demonstrated it to me and we have had a conversation about it. Okay, so a few of you might be like, well, I went and I did some work on my own and can I retake it? And I'll say, no, I have no idea where you're at. You need to show me. Okay? I don't want to give you false hope, and I don't want to grade just repeatedly bad work. So, any other questions? There's a tutorial and a flex period this week. Those would be good times to come in.
There's a day off this week, though.
No, next week. Yeah, Major? Like you have a question on your test?
Yes.
If you have a question because you're like, I think you graded this wrong, or I'm just really curious and I want to know, come talk with me right after school today. Also, you guys are always welcome to like hang out for a few minutes and ask questions quickly. Anything else? Okay. So. Yeah.
If you got like an A on like 2 of the different sections inside the test, but then you got like a C in the last section, does that mean for like the whole test you got an A, but like in that segment you got a C?
Let's say it looks something like this for your test score. Maybe you got okay, your grade. 90% of your grade is, well, this doesn't represent 90% of your grade. If you had G4 on there, that would be 90% of your grade. So there's right now, just when you're like talking to your parents, G4 is going to end up being 90 divided by 4, I don't know what it is, 23 or something. There's 23% of your grade that's not even in the grade book right now. It's not even like there. So that's one thing to think about. Depending how much homework you've done, this might, if you've done all your homework, you could still be at an A. If you've done not very much of your homework, this might kick you down to a B. This is where homework starts to play in. So you're like, oh, homework doesn't affect my grade at all. Well, it does. 10% of your grade based off of things, right? Because if you have 2 A's and a C, you're probably at an A if you have all your homework in for sure, right? If you don't, homework's late, this might be kicked down to a B. Anything else? Yes? No, you can retake for a higher score as well. But for a higher score, you only get a retake once. And also, you're not my priority. And I'm just being honest. If you came in during tutorial and there were like 8 people in here and you were like, I got a B, but I want an A. And then there's people who are like, Miss Dolby, I really need help because I don't know what's going on. I'll be like, okay, if you want an A, then show some gumption and do it yourself. And I need to help people. That being said, Mariah, you come in every morning, I'll easily help you. So there you go. Okay, anything else? Tips. Just kidding. Working out. The world is my gym.
You even lift?
I don't know. I just feel like okay. Oh, God, stretching out. You guys talked about homework? Yes. Here you go. Yeah, I just gotta stay active. I got a big meeting today. I'm gonna be sitting for a long time.
I don't know my pencil went. Oh. Found it.
Cool. I didn't write the fraction because a lot of people have different fractions.
I'll say.
But I know you're right if you got the percent right. Checking. Wake up your, people by you if they're asleep. Kimani, Levi, it looks like you're dead.
Levi, on your freeze day.
You are number 1. What? Yeah.
I didn't get caught.
Are you energetic today? You guys like coffee?
No, I told you. I just shared with Meadow. I'll share with the rest of you. I'm kind of having a little bit of a bad day, and so I just figure you can only change your outlook, right? Like you can only be. So yeah, I'm not feeling it today, but what are you gonna do? Fake it till you make it.
I'm feeling enough.
Life tips. 3, 5. What did you say? 5. 6. 6. Okay, 2 and 5. As always, my dear little students, if you have further questions that are not answered, you may come in and I'll gladly answer them for you. Number 2, first. What? Well, I'll look. Guess what I'm going to do? I'm going to write this down. And then I'm going to go like this. And then I'm going to go. They can't see. I'm a trained professional. Okay.
How many days did you practice that in their book?
It's taken me a long time to get good at writing on this document camera. Okay, ADA code says for every 1 inch of rise, I'm just also going to draw this second diagram. You guys are done talking. For every 1 inch of rise, there must be at minimum a 12-inch run, because otherwise you'd have some crazy steep wheelchair ramp. Not cool. Okay, so there's that to consider. Also, let's be a little bit savvy here. 12 inches, also recognizable as 1 foot. Okay, here, and then it says you have some floating door. Awesome. That's 30 inches up. Now, 1 inch requires 1 foot, at least. 1 inch requires 1 foot. 30 inches, therefore, will require
30 feet.
yes, 30 feet. It says here, you only have 16 feet. Is that puppy gonna fit? No. Right? No, we only have 16 feet. At 16 feet, you'd have like crazy ramp, and people will be falling backwards. It'll be unsafe. Okay?
A lot of fun with your sound effects.
So no, it would be too steep. Or if you made a 16-foot ramp, it'd be way too steep. You could also say a 30-foot ramp would go into the street. That'd also be an issue.
That's not my problem.
Okay, yeah, exactly. We'll see some more about that later.
Well, I don't drive.
Okay. Number 5. We have not gone over homework in about like 3,000 weeks. I'm not doing all of 5.
Not the times because you don't want to.
Wait, can you just explain to me what that sentence
Did we right?
Find the dimensional circle?
Okay, yes. Here is this explanation. Also,
I know.
Cecilia, stop doing that. I made a full and complete table, and here's what I was thinking right here. It took me a second. I was like, okay, if it's 130, okay, because like this, and this is me thinking, you can't see it very much. There's not a lot going on up here, but if this is 1, that's actually the side of a rectangle. I didn't finish my rectangle. I was like, this is 1, this is 1. 1 plus 1 is 2. That leaves minus 2. That leaves 28 meters of fencing split between the other two sides. I'm going to draw it out because my brain is
Wonderful today.
28 meters split between two sides would be 14 meters on each side. Okay? And then so 1 times 14 is 14. And then over here, I was like, okay, see, I drew a little bit of a bigger line. I was like, okay, 2 and 2. 2 and 2 makes 4. 30 minus 4 is 26. Divided by 2 is 13. What?
Why'd you put 14 and she's like 30 meters?
Yes, she just explained that.
Okay, yes. I'm not really, I'm just giving you a hard time. Because
Yeah,
there's
I see what you're saying.
all the way around. Yeah. And so on and so forth. Is really what I'm going to say there. Went with a pattern. And I noticed my areas are getting bigger. In fact, they're getting bigger. Here, are we talking about B? Because the largest rectangular garden, your area is going to be the biggest. You'll notice here, they get biggest as the sides are similar. The closer the sides are together, the more area you're going to have. Because the closer you are to square, the greater area you are going to have. Okay? So if I really wanted the biggest one, this is really what I did, is I did the square root of 75. I said, let's make that a perfect square. If I make it a perfect square will have the most area given the perimeter. Yes.
I wanted to point out that actually the shapes of ground plots in part A and part B are not both squares because A is rectangular.
The biggest ones, whatever.
But the biggest one is in the square still, it's 7 and 8.
Here, guess what? I didn't do my homework. Now you have
Also, it
nothing to
tells
say.
you that they both have
Now
the
you have
rectangle, so
nothing
can
to
just
say.
copy.
What?
Didn't you have longer lengths? Besides 8?
Just the longer the closer it is.
No. What's my next one? Yeah, they're all over here.
For B. Talking in B.
So it's asking for a rectangle, but the one that'll come out is not a square yet.
Biggest area is going to be 8.6 by 8.6.
Also, every time I read it, we gotta read it.
Squares are
the same
rectangles.
lengths you got to make.
We got all the sassy ones up here today. The end. Next.
Wait,
What? Okay, we'll chat. We'll chat. What am I doing? Where am I? What's that? What am I supposed to do next? Start to move over. I gave you your test.
Yeah.
Oh, I'm sorry. Put your test in a nice, neat stack, not a crazy wonky pile.
Yes.
Make it a square. Really what we can do is we can take the perimeter. I was thinking area, and that's why I square rooted. Area is square. Perimeter, the biggest thing it's going to be is 75 divided by 4. If I take the perimeter
Oh yeah.
and I break it so that all 4 sides are the same, 75 divided by 4, is that 18? Yeah. Gives you 18.75 meters. So a square with 18.75 meters on each side, because 18.75, 4 of those is going to add up to 75. That would be the biggest area. I had given you the dimensions for if this was the area. If 75 were the area, those would be the biggest dimensions. But 75 was not the area, 75 was the perimeter. That was my bad. So if you divide it by 4, that's what you should have been doing. Okay. Cool. Okay, so next up, we have 8 definitions. I could give you a definition in a minute so long as you are A, following along, B, sitting up straight, working on the eye contact thing, maybe nodding. An occasional smile would make me feel nice. Okay? Complementary angles. You also, all 8 of these definitions, you know. Someone help Major out because he is really bumming me out here. All definitions that you know. Complementary for the win. Anyone? Complementary. Duke.
help each other.
No, complementary angles.
There's 2 hands.
Dahlia.
Here. There's 2 hands.
No, you're right about add up. Keep going.
They add up, wait, did you say 90 or 180?
What did you say? And I said no, and I said no.
So it must be 90.
There we go. Complementary angles. 2 angles that add to up. Add up to 90 degrees. Great. Words are nice. Pictures are better. Given some sort of angle. If I have here angle A and angle B. And I'm also going to introduce some new notation. Angle A and angle B are complementary. Angle A and angle B are complementary. Notice before we talked about when I'm talking about a triangle, I do a little triangle. When I'm talking about an angle, I draw a little angle. It's really nice. Okay? Now we know complementary angles, 90 degrees. You just need to dial that in that complementary is 90 degrees. Complementary, 2 angles, 90 degrees. Great. Next one, supplementary angles. Yeah, you've all seen them before. Supplementary angles, if complements add up to 90, supplementary do what? Levi, go ahead. Yeah, 2 angles that add up to 180 degrees. Actually, I always wonder if it could be a trio. Could it be 3 angles? I'm not sure. Not sure. In this case, 180 degrees is a straight line. So if you have angle C, I'll get there, yeah. Again, here, if I have two angles, they're in a straight, they make a straight line. I would write that angle C and angle D are supplementary angles. Complementary 90, supplementary 180. 180, 290s. Okay. Those are two down, 6 to go.
2 down 6 to go.
Okay.
That's funny.
Because I'm curious, back up.
Just oh, wow.
I'm sorry.
The way she said it, I thought it was funny.
Next one. We're going to talk about triangle names and or classifications, but let's be simple and call them names. Okay. Okay. Triangles can be classified or named for their sides and or for their angles. When you're really fancy, you combine both of those. Okay? This is going away now. So, when we're talking about triangle names, I'm going to write what I just said. Triangles can be named for their sides and or for their angles. And slash or their angles. There are 3 of each. For sides, for the side names. I'm going to write this in the center, and I'm going to make 3 little columns, and it's going to be beautiful. It's going to be so nice. Check it out. Yeah. First side option. Anyone want to guess? Sam.
Equilateral.
I'll give it to you. Equilateral. That's going to be in the far, thatmost column, rightmost. Another name. Maximus. Isosceles. In the middle, we've got isosceles. And Cumani. No, that's the angle. Ethan. Scalene. Scalene. Scalene.
In case you can't tell, triangles are my favorite shape.
That's because they're perfect. Okay, scalene. No sides the same. Notice that it's not a grammatically correct sentence, but we're going with it. No sides the same. A scalene triangle would look something like, and I'm going to show by tick marks. You're learning more things. Different numbers of tick marks means the sides are different lengths. Scalene has no sides the same. No sides the same. And here's why we hopefully wrote it in order, and it's going to be like so beautiful. Nicely organized. Isosceles, then. Oh my goodness, you guys are very, very good. 2 sides are the same. They share a single tick mark because 2 sides are the same. That third side, no one really cares.
Oh, wow.
I care about you third side.
I know, but you guys.
Are you gonna make a tip for him too?
Yeah, I actually did.
Oh, good job.
Okay. Equilateral, then, of course, we all know it's in the name. All sides the same. And an equilateral triangle. All 3 of those sides are the same length. Okay? Now, those are sides. We also can name triangles by their angles. I'm going to make these 3 columns, but they're not, like, related that way. Okay? These are also happen to be angle names. Okay, angle names. Finn. Obtuse. How dare you call me obtuse?
You told me to put my hand down. I was gonna say that.
Cute.
Go ahead, Luis. Acute. Lastly, all together now.
Right.
Hey. Okay.
Don't worry, it's not wrong.
So, the obtuse triangle. Remember we're talking about triangle names. Tommy. The obtuse triangle has an obtuse angle. What's an obtuse angle? Austin. Yes. So it has an angle bigger than 90. Angle bigger.
One angle,
Yes.
exactly one?
Yes. It couldn't have more than 2.
Oh, yeah, you're right.
Or more than 1, rather. Because then you wouldn't have triangle. Okay? Angle bigger than 90 degrees. Look in something obtuse, like some crazy looking triangle. Look how big that angle is. This is obtuse.
The angle level. It's over 9,000.
Okay. This is the obtuse angle. It's huge. Notice the obtuse angle, sometimes people get confused because they see this really big angle. The really big angle makes 2 little baby angles. And you're like, well, those look like acute angles. Yeah, they are acute angles, but it's named for its biggest angle. In fact, you could say that all triangles are named for their biggest angle. If the biggest angle is obtuse, it's obtuse. If the biggest angle is acute, it's acute. If the biggest angle is right, 90 degrees, then it's a right triangle. Okay. See here, acute is that all angles, less than 90 degrees. Something boring. Again, there's the biggest, doesn't really matter what the angle measurements are. Even the biggest one is less than 90, and the right triangle has a 90-degree angle. We all hopefully recognize the right triangle as the best of all triangles.
Why is it
That's
best?
true.
Why is it best?
Yeah. Okay, it's just the most useful. It's just the most useful. So, here, right, again, I said angles, sides, or their angles. That means, yes, you could have an isosceles right triangle. Okay, you could have an acute scalene triangle. They could be combined. Okay, this is I think I might turn that into a t-shirt. It's very nice. I'm just going to copy it. I'm just going to photocopy it and just right there.
I would wear
Beautiful.
that shirt constantly.
I actually would wear shit like that.
I love
Just because
triangles
it
so
was for
much.
math class.
I love it. Then you could wear it on a test.
We should all.
All right.
Yeah, that for your test. That'd be awesome. Get all your notes printed onto your shirt.
Yeah. Okay. Next up. Those are some definitions I just needed to tell them to you. It's assumed knowledge. You all know them, and now I officially can say we've talked about it. Okay? We have been building in here, and if you, lots of you guys messed up your stairs yesterday. And we say messed up. Shh, hold on. Same thing happened with balsa wood. Lots of you guys, oh man, those balsa wood trusses, I can't even tell you how much we wasted because you would make a truss, you'd be like, it's not perfect, and then you'd scrap it. Now, Kimani, for the stuff we've been building, you may have heard Mr. Hirshu say it. You may have heard me say it. And we were talking with a group even just yesterday of like, well, you just kind of got to make it work, right? Because ultimately when it comes down to it, Mr. Hirshu will often say, you're not building a piano, okay? It's not going to be perfect, all right? And that's true, especially for carpentry, right? It's not going to be perfect. It should be really close, and we're going for really close and as close as we can get. But there's times when, it's going to be a little bit off, and instead of buying another $40 sheet of siding, we're just going to make it work. Because it's okay if it's a little bit off. That's an estimating world. It's kind of okay to estimate in carpentry and in some of this framing stuff. When we start talking about engineering, bridges, you know, okay to estimate?
Depends on how much you're
Yeah.
estimating.
Okay. And or let's say this. Let's say you were going to produce your manufacturing windows, your window company, and you are going to make 100,000 windows, and you estimate the area of one window times 100,000, and you're, maybe you say you're, that's about within a ½ inch, right? And we're talking about material, and then that little ½ inch estimate scaled up 100,000 times. Suddenly, is it okay that you were close? No, it's going to cost you a lot of money if you're not exact. Kenya. Josephine. Come on, man, pick that up. So, another way to illustrate that is we are going to, I just think this video is cool, is one reason. Back in 2012, there was the space shuttle. The Endeavour space shuttle was moved from Los Angeles Airport to a museum that was 12 miles away. Some of you, maybe you've seen it in the movie or something. I used to live down in LA. Streets are tight. There's a lot of signs. You're moving a giant space shuttle. Okay, they moved it 12 miles, and at parts they were within an inch on either side of the wings. 1 inch clearance. Okay. Here, you watch.
That's a little scary.
No, I think it was just a day.
How was it?
A day.
So, yeah, that took over a year of planning,
But 1 day.
and it took them a day to move. So what they were doing, and you can't really see it there, you can kind of see it at the end, is they had to push, like one of the things, they leveled out every street. So there's normally curb, street, and they would have to level out the streets, and so they would go ahead and put down the street and then move it and then take off the street, and they're like trying to basically build a runway for the thing for the whole 12 miles. There were trees, like some people were pretty pissed off. They had to cut down some trees because it just couldn't fit. You saw the one tree where it was like, "Rrr." And if you noticed in the video, there's like suspension, so at times they had to raise it up or lower it down to fit just under the branches, like you saw it coming down that main way, and it's just wings were going through the trees. An example of where precision is pretty big, right? Like that space shuttle that had 25 missions where it went and flew in space, and like that was the thing. And so they didn't really want to break it. They wanted it in one piece. Obviously, you don't want to, like, you saw it go right by those people's houses. Wouldn't be a good situation if you're like, oh, it's a little bit off. Okay? Yeah. It had some scratches. And I mean, it's been in space. Had some scratches there too. But so now here, most of the work, and I'll be fair, most of our purposes, right in this class, we're not doing large-scale productions. Right? We're not manufacturing 1,000 pieces. But it is something that you do need to know. So back into your notebooks. We are going to talk today about simplifying radicals. And just to preface this,
What type of engineers?
civil, as well as really any others. Okay, engineers, other professions. Today we're going to be talking about some exact answers. Now, right? Whatever. And talking about how do we have exact answers? How do we stop rounding? Especially as we get going, and you've kind of seen already when we work with pi. Right? When you work with pi and you round too early in a problem, then your answer is off for the rest of the problem. right? So especially if there's a multi-step situation and you round, and then you use that rounded number to calculate something else, and then you round again and you use that number to calculate something else, right? You start all of a sudden what started off as a 1/16 inch rounding, now you're off 1.5 inches, and you're like, what happened? Okay. As an example, let's see how you guys do. I would like you to give the exact length of the rafter. With all that in mind, if you were gonna, I don't know, if you wanted the exact length, exact. The rafter is the one side of the roof, and it has a 3-foot rise. Go ahead and take a second. See if you can't come up with what's going to be the exact length. What's the exact length going to be of that one piece? What's up? I like your thinking.
X equals 7.937536.
No,
7.937539.
no, you're rounding. Calculator rounds. Bumps of you. Anyone feeling good?
I'm actually feeling pretty.
What you got? Okay, here's what Duke's telling you. Some of you guys go like this. I don't even know what it is. 49 plus 9? 64. Yeah. So some of you guys maybe, yeah. First of all, if you squared 16, check yourself. Don't square 16.
Oh.
Yeah. Because why am I not squaring 16?
Yeah.
Yeah, I'm only looking at half-sies. That's 8. Don't square 16. First off. So I'll give you a quick second. You're like, oh.
Okay, now I know what it is.
Shh, don't answer. Yes.
I'm a little bit.
Kind of, though. You're still kind of wrong. Okay. Here, and then you're like, oh, cool, my calculator, and this is what Duke is saying, your calculator it cuts off. Same thing with pi, right? If I put pi into my, watch, I'm smarter than my calculator. Pi, this isn't even, 8. This isn't even right. Okay, here's pi. 3.141592653. Watch this. 358. This right here. 2654. That's wrong because it's rounding already. Just so you know. 1.149. 265 358 97 93 238 4626 433 83 279.
That's not what I know.
You're wrong. We'll talk. We'll battle after school. I know you hate when I tell you you're wrong. We'll talk after school. How about that?
It's 820.
We'll talk after school. Okay. Look. Shh. All to point out right here, your calculator rounds. We know you've heard the word, that pi is a never-ending decimal. Your calculator makes it end because it rounds. So some of you guys, even if you did one of these, and you said, well, it's 8.544003745, you're rounding. The calculator's automatically rounding, so you're already getting a rounded answer, which is not exact. Right? Because here, again, you'd get to something like 3 squared plus 8 squared equals c squared. 9 plus 64 equals c squared, 73. One way to write exact. Go ahead, Sam.
It would be the square root of, I think that's 73.
Now, that's one way to write it exact. If I write it as
Can't see.
okay, this is exact. This is an estimate. Okay? This is exact. Yes, the square root of 73 is an irrational number, or a number that never ever ends. Can't be represented by a fraction. It's an irrational number. When I put the square root of 73 into my calculator, it gives me a decimal that we chop off and round. Right there, right when you rounded, now you're estimating. To keep it exact, we would leave it as a square root. We say that's the exact number. Okay? Square roots, kind of like fractions, square roots need to be simplified. Okay? So, you can simplify square roots the same way that you simplify fractions. Where do I want to go? Okay? So, today we're talking about how to simplify square roots. If I had something like this, new example. So square root of 73 would be exact, but there's a convention mathematically, agreed upon way of doing things, that in the same way you don't write 10 over 5, right? You write 2 because you simplify, okay? As an example, let's start with the square root of 75. The best way I can think to do it for you would be to say, okay, if I'm talking about the square root of 45 and wanting to simplify it, we are going to break this down. We are going to break this down into its prime factors. You've done prime factors before. You're going to break it down into its factors until you can break it down no more. How do I do that? I look at what multiplies, right? 45, what do we know? 5 and what?
9.
5 times 9. 5 is prime. 1 times 5 is the only thing I have. 9 is not prime. Boom. 3 times 3. Okay. So now I've broken this down. This is the factor tree. You've done them before. And here the factors then of 45 are 5, 3, and 3. You can only go to the dance in pairs. You can only go to the dance in pairs. Shh. You can only go to the dance in pairs. I'm laying down the law today. These two are a pair. There's 2 3s. They get to go to the dance. Okay? There's more analogies I could use, but we'll wait till we know each other a little better. These two get to go to, they're going to go hook up out here. Okay? 2 become 1. It's going to be weird. Okay? These guys, again, the 2 3s become a single 3 on the outside of the square root, and this poor, sad little 5 who didn't get to go to the dance is hanging out on the inside. Okay? All right. Yep. We'll call the Levi. Can we call the 5 Levi from now on? All right. He said it first. I'm just saying. Okay. Again, I could prove this if I just because you're probably like not entirely believing me right now, and that looks weird. The square root of 45 is the same thing as 3 times the square root of 5. Same. They're the same. Okay? This here would be the simplified and exact answer. As simplified as we can get it. And I say this as 3 root 5. Okay? When we are simplifying radicals, you are going to be breaking them down into their prime factors. Okay? Breaking them down into their prime factors. Okay? I'm going to give you another one. You guys can try this one. Simplify the square root of 28. In other words, I'm asking you to break it into prime factors. We'll start easy. You try. Break it down. Give you more time as we progress. 28. Oh, let's go this way. Maybe you weren't sure what 28 divides by, but you know at least, hopefully, even numbers. Always a good idea to check dividing by 2. So maybe you were like, oh, 2 times 14. And I know 14 is the same as 2 times 7. So now, and even if you didn't do it that way, you should have been left with a 2, and a 7. I could even check that I'm right. I could check that I'm right because that means that 2 times 2 times 7 should give me 28. It does. Right? So I broke it down into its prime factors. I have 2 2s and a 7. You go to the dance in pairs. 2 2s and a 7.
That doesn't make sense though, because the 7 is inside.
Yeah,
So,
the 7's in jail. Okay, fine. You gotta break out with a partner. What do you want?
okay.
All right. Okay. 2 2s. To be fair with you, my high school math teacher said you go to the dance in pairs, and it stuck in my head forever. So that's what you're getting. Okay, you're welcome.
Your only friend that has.
Hey. 2 2s. So these 2 guys, right? They get to go out to the dance. They get to leave out, but something happens in the way, and there's just one of them left. Okay. And I would write my answer as 2. Now, I could also say to you, I could also say, if this is fine with you, cool. If you're like, wait, what's happening mathematically? Because you're amazing. Mathematically, if you don't care what's happening mathematically, then just keep thinking about the dance, okay? If you care about mathematically, I'll say real quick.
Yeah, I'll think about the presentation.
28. I can also write that as 4 times 7, which I can write as the square root of 4 times the square root of 7, which is 2 root 7. That's mathematically what's happening. I've found that even though I want you to know the mathematical thing, most people never remember and they just do the dance thing. So. Okay. So here would be the exact answer, right? We're feeling okay with it? Ready for a challenging one?
Yeah, I'm sure.
And I also was going to tell you guys, you did see, you guys saw the aftermath of period 3 trying to leave class. There's going to be an exit ticket. So you don't get to leave until you have it right.
This way?
No, not this one. I'm just warning you, you might want to start practicing.
Okay.
Because about one more, I'm going to give you your exit ticket. It's going to be like this.
Wait, do we get to leave early?
Yeah, if you finish it, you get to leave early. Yeah,
Oh.
not this one. This is not the exit ticket. You'll know. Hold on. Ways of cupcakes. All right.
I don't know if I did this.
So, depending how you do, since we're trying to get down to prime factors anyway, I like to divide by 2 first. Why? Personal preference. So I'm going to say that's 2 times 36. I got the 36 because I divided by 2. And then I'm going to be like, okay, cool. 36, that's 6 times 6.
Oh.
And then I'm going to say, oh, 6, that's 2 times 3. And this 6 is 2 times 3. And in fact, I'm choosing to do this method because it's all crazy. Okay? So now I have a, don't forget your 2 up here. There's that 2, this 2, this 3, this 2, this 3.
What?
Okay. So, you're looking for pairs. Don't forget that little 2 up there. However you did it, you should have been left with 3 2s and 2 3s. However you did it, you could have gone 8 and 9, you could have gone whatever. 2 3s, 3 2s. Then you need to keep going. No. Okay, listen. Okay? I could also, if you wanted to, you could reorganize. You could reorganize and say, okay, I know that 72 is equal to 2 times 2 times 2 times 3 times 3. I could say that if you wanted to reorganize. Okay? So these guys, or, I don't know, you can do it from here, or you can do it from here. But what you should see is that there's a pair of 2s, and there's a pair of 3s. Pair of 2s, pair of 3s. And there's a single lonely 2 who doesn't get to go to the dance. His name is Levi. Okay? He started it. Levi, is that too far? Levi, you started it. Okay, good. He started it. He started it. I'm only repeating. So that means okay? Hold on. Shh. 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 A pair of 2s are going to come out. A pair of 3s come out. There's still this guy is sad. He's still hanging out in here by himself. The only new part was that, hey, 2 things came out. Those 2 things get multiplied.
Oh, wait, yeah.
No. So look. Okay. We're going to do one more. What? Yeah. Good. I'm sorry? No, the 2 and the 6 cannot switch spots. Shh. Shh. The 2 has to be under the square root. Give me yours. Sorry, you want to share it? Step 1. Tear this into 4 pieces. In order for you to walk out the door, and you get to do so as soon as you are done with this, you must have the exact length. Some of you might be able to leave early.
Is it?
No.
Darn it. Can I have a
Yeah.
Wait, can I get out?
Also, I'll remind you, because I...
Unless you divide it in half to get over 9,000. I don't think you can.
You did it?
Yeah.
Yeah, you
Quick, what's
maybe put both of these away.
What was the
Ready to
start,
go?
Sam? His calculator level.
Hand it to me on your way out.
Oh,
No take backsies. You
I'll
only
make sure
can
to
hand it
take
to me
your
on your way out.
language.
You should be packed up. That's when you're coming out. Hand it to me on your way out the door. I'm not checking until